Okay, let's try to implicitly derive this equation with respect to x. Okay, and this is the key to this problem, is to realize that it's respect to x. And the equation has both x and y in it. So if I look here, I notice I have two variables, and they're being multiplied together. So this is a product rule problem. So I'm going to derive the first, 3x squared, leave the second one alone, times y to the fifth. Plus now I'm going to leave the first one alone, times the derivative of the second. But remember, when I derive the second, I have to multiply it by y prime. I have to use the chain rule there. Equals the derivative of 22 is 0. And now I'm going to solve for y prime by getting it by itself. So I'm going to get rid of the adding first by subtracting it from both sides. So I'll get x cubed times 5y to the fourth times y prime equals negative 3x squared y to the fifth if I subtract that first term from both sides of the equation. Then I'm going to get rid of the multiplication by dividing both sides by the number that's in front of y prime. So x cubed 5y to the fourth on both sides of this equation. And then I'm going to solve by simplifying the left side. I get y prime equals. I'm going to try to simplify the right side. If I notice here, I can simplify the numbers. So I'm going to get negative 3 over 5. And if I look at the x terms, I have x squared on the top. And if I divide the bottom by x squared, it leaves an extra x on the bottom. And likewise, for the y terms, I can divide both of them by y to the fourth, which leaves an extra y on the top. And so this would be considered the simplified version of this equation. Okay, so what's the verbal rule for the chain rule? This is for derivatives. You derive the outside function with respect to the inside, then multiply the derivative of the inside function. Well, when we want to go look at antiderivatives, we want to undo that. And so the key here is to look for the verbs in the statement. So there are actually two verbs, derive and multiply. Everything else is nouns and adjectives. So if we want to undo this, we got to undo both those verbs, and we do that by changing the word derive to antiderive, and change the word multiply to divide, and this becomes our anti-chain rule then. Antiderive the outside with respect to the inside, then divide by the derivative of the inside function, and this becomes our anti-chain rule for derivatives. So before we start looking at antiderivatives, let's remind ourselves how the chain rule will work. So here, what is f prime of x where f of x equals this equation? Well, remember, we derive the outside, leave the inside alone, and then multiply by the derivative of the inside, so times 3. And this is an important aspect of here. If you notice here, we're multiplying by the derivative of the inside. Well, when we go to antiderive, we need to actually keep in mind that we want to undo that by dividing by that derivative. Okay? So we're going to get rid of this. So let's take a look at some problems here and see if we can find the antiderivative of this. So this one, f of x, if I antiderive, this is the anti-power rule. I add 1 to the exponent, so it becomes x to the fifth, and then I divide by that new exponent. So divided by 5 would be 1 x to the fifth, and remember, you always got to go to the ocean, plus c. So again, we wouldn't necessarily have to write the 1 there. We could just write x to the fifth plus c. So let's take a look at a trig function, f prime of x equals secant x tangent x. If you've memorized your trig derivatives, you realize, oh, that's the derivative of secant x. And again, we got to go to the ocean, so plus c. So these next two problems help us understand the anti-chain rule, which I was showing on the previous slide. And here I have f prime of x equals cosine for x. So I want to antiderive this, but this is a composite function. You notice I have an inside and outside function. So I want to antiderive the outside. Well, cosine's the outside. The antiderivative of cosine is sine. With respect to the inside, so 4x, divided by the derivative of the inside. Well, if I notice here, the inside function is 4x, so I want to divide by 4. Okay, well, we usually write that as multiplying by the fraction 1/4. It's the same as dividing by 4, but it makes the problem a little bit neater and nicer if you don't have so many fractions in there. And remember, we got to go to the ocean, so plus c. So the last example here, this is also an anti-chain rule. So I'm going to antiderive the outside. So if you notice in this case, the outside function is to the third power. So I antiderive that by adding 1 to that exponent, so the fourth, with respect to the in, so I got to leave the 7x plus 2, and I got to divide by that new exponent, so 1/4. But remember, I have to divide by the derivative of the inside. So if I look here, the inside function is 7x plus 2. So I have to divide by 7, which again I record as a fraction, times 1 over 7, and again plus c. So this should be 1/4, the quantity 7x plus 2 to the 4th power, times 1/7 plus c.